Hello there, welcome to this video on creating your own personalized bracelet using the Torus Knot plus Curve command in Fluid Designer. So what we're going to do is to show you how you can use Torus knot curves to create bracelets. And so if you start Fluid Designer up, your opening screen should look something like this. Well, we're going to make a bracelet today, so we're going to go to rings first of all and change our folder to bracelets. And if we select the 65mm all UK sizes bracelet, we can just drag and drop that onto the workspace. Just move that panel back a little bit, and I'm just holding down the center mouse button and showing you what the default bracelet is. So the default inner diameter is 65mm. And at the moment, this bevel object, 1mm by 10mm, so 1mm thick and 10mm deep, is wrapped around this default inner diameter. Now, I don't want this object, so I'm going to delete the bevel object that's been wrapped around this 65mm curve. Now, the bracelet I'm going to create, I want one with an internal diameter of 65mm. So I'm going to keep this object. If I wanted a different diameter bracelet, I'd need to switch on one of these objects here and use that as my inner diameter. I'm not going to worry about that. I'm going to stick to this internal diameter of 65mm. So 65mm X and Y diameter. Now we're going to use a Torus knot curve to create our bracelet. And one of the things that we're going to need to do is to open up the toolbox. So this panel at the side here is the toolbox, and I can open it up in different ways. I can drag this panel open, or I can press T on the keyboard. Oops, let me just switch on the screencast keys. So pressing T will open and close the toolbox. And I want to open up this panel here at the bottom because I know that this is where my values are going to be displayed. So, what do we want to do? We want to use a Torus knot curve. So if we go to Add and Curve and Torus knot plus, and if I just point at the center of the screen and scroll the center mouse button, you can see as I rock the object around, I'm just holding down the center mouse button and moving it slightly. This is our Torus knot, which goes in and out of itself. And the number of times that it turns round, the number of times it goes in and out of itself, is determined by these values here, P and Q. The bigger these values, the more turns we get and the more times it goes in and out of itself. Now I'm going to set it back to the startup values, which I think were 2 and 3. So that's the how the Torus knot starts off. We'll change these values later. We need to look at some of the other values in this window here to understand what's going on. Now I'm going to start off by looking at the geometry options, the surface options here, and the bevel. Well, quite often in Fluid Designer you might go to bevel over here and set a bevel thickness which wraps around the current curve. So here I've set a bevel object of 1mm by 1mm, and that's been wrapped around our Torus knot curve. Well, in this instance, I'm not going to use that as the bevel object. I'm going to use the bevel depth that's displayed here in this window. And you can see it's 0.08 over here and 0.08 over here. Now, though that value is far too small for 3D printing, this is just, I mean, this is 1mm, this box, 1mm by 1mm. This is much smaller than that. It's actually 0.16 of a millimeter thick. That won't 3D print. So we need to increase this value, and I would recommend a minimum value of 0.5. Because what 0.5 will do will give you a thickness here of 1mm. So 0.5 is the radius from our curve to the outside of the bevel object. So the diameter is 1mm. Now the next value to look at is the bevel resolution. Now if I set it down to 0, you can see I get a square cross section there. I don't want a square cross section on mine. I want it to be nice and rounded. And the bigger you put this bevel resolution, the smoother your surface will become. and the highest value you can set it at is 4, and I would strongly recommend that you actually set that at 4. Now we don't want to extrude anything, we don't want to drag anything out of this object, so don't worry about extrude, but we do need to understand what resolution 12 means, and in fact we're going to change it to a slightly larger value. But notice up here we've got another resolution as well, so we've got two resolutions, one connected to the geometry of the surface and also a value of 100 up here. Now I'm going to change that value and I'm going to set it at, I'm going to do 11, and this resolution down here I'm going to reduce this right down as well, and I'll leave it at 4. So I've changed the resolution at the top here to 11 and this one for the surface to 4. Now what does that mean? Well, what we need to do is we need to first of all switch the bevel back down to 0 here so we can actually see the curve, the underlying curve of our object. And what I need to do now is to press the tab key to go into edit mode to understand what the 11 and the 4 mean. Well, let's have a look what we've got. Well, we've got a control point there, and if we work our way around, we've got 2, 3, 4, 5, 6, 7, 8, 9, 10 control points around this object. Well, I had a value of 11 for my resolution at the top, and that's where the 10 figure comes from. It's actually just one less than the 11 value I had there. So the bigger the resolution there, the more control points that we have around our object. And clearly the more times that we go in and out of ourselves by changing the P and the Q value, the more control points we really need to do to get a nice and smooth finish. Now we also had a resolution of 4. Now if I just highlight 2 control points there, no, I think actually I had it as 5, I think. So if we look at the arrows, the blue arrows between these 2 control points, we've got 1, 2, 3, 4, 5 arrows between a set of control points. That comes from the resolution of the surface. So if I just press the tab key to come out of edit mode, and if I just delete this object and then add it again, oh no, I did have a resolution of 4. Well, the resolution of 4 is actually the number of arrows between 2 adjacent control points. So if I increase this, let me increase it up to 15, and let me go into edit mode again, and you can see now between those 2 control points we have got a lot more arrows. And so the surface resolution increases the number of arrows between these 2 points. And what that does when we create a mesh out of our object is it increases the number of faces between those 2 control points. And clearly, the more faces you have, the smoother your object will become. So if we count these, we'd have 15 arrows here. So the more we have, the smoother our surface will be. Now we do need to come out of this again, so tab key to come out of edit mode, and I do need to delete it again and create it anew. Now this is a bit of a nuisance with these objects, but if you do go into edit mode, or sometimes if you add something over here or change something over here, this panel will disappear and it will be applied and fixed. But you can always add the object again for the last set of values. Now I would recommend that you actually increase this to about 30 to get a nice smooth finish. And if we now put the bevel back in at 0.5 again, and as you can see, if I zoom in, we do have quite a smooth surface there, and if we look at the top, we've got about 3,000 faces at the moment, and that's with a resolution of 11. And if I just move that down, you'll see the faces go down to 2,000. So the higher this value, the more faces that you get and the smoother the object is. Now I would actually recommend a value of about 180 here, because that gives you 60,000 faces, which is perfectly reasonable to work with, and it gives you a nice smooth finish. If you go above 180, you will find that it doesn't actually smooth it off anymore. And you could probably get away with a value less than 180, maybe even 90. But, you know, we've got 60,000 faces, so that's okay. So those are our values which are important in terms of the surface finish and appearance of our object. Now what we want to do is to look at some of these other values here and actually generate a bracelet that we'd like to print. So what I'm going to do is I'm going to change this value of height here from 1 to 10. And if I zoom out, you can see what effect that has had. It's actually created a Z value of about 20 millimeters, so 2 centimeters. So the height of 10 here represents the height from the grid to the top of my torus knot. So the total height is about 2 times this value. So that's the height. Now scale, well, if I just zoom out again here, I want my bracelet to have an inner diameter of about 65 millimeters. So if I hold down the left mouse button and drag the mouse to the right, you can see what I'm doing is scaling out my object so that it fits into the inside of it is the 65 millimeter inside of my bracelet. Now what you find with this value here, if I type in a particular value of say 20, if you notice over here the X and the Y values are in fact, the X is the red, so the value there, and it's actually the value from the outside of the curve, is about 80 millimeters, and the Y as well is about 80 millimeters. So this value of 20 here, essentially you've got to multiply it by 4 to give this value of 80. So if we set a scale value of 10, 4 tens are 40, so our X and Y values are 40. We want a bit more than that. We want something round about 17, 17.5 approximately. Now we will adjust that later. So those are our height and scale values. Now I'm just going to switch the grid off because it is in the way at the moment. So switch the grid floor off. So there is my basic P2Q3 bracelet. Now what we're going to do is to actually create a bracelet itself now that we would like to 3D print. Now if we change these values here, you can see as we change these values we get different types of bracelets, all of which will print. And you can keep scrolling through here until you get a bracelet that you like. And the patterns that occur, one of the things that does happen is they do actually repeat themselves. So we've got a pattern there of P5 and Q47, and notice that that pattern just keeps repeating itself as I enter in higher and higher numbers here. But one of the things that's happening is that this is becoming thinner. So you've got to consider that. I mean, we're down to 10 millimeters now. We did actually start off with a height of 2 times 10 of 20. But changing the P and Q values does in fact change the thickness of the object as well. So you do need to consider that, and you can actually change the height here later. We don't have to keep it as 10, so you can reset that yourselves. But you can play around with these numbers here until you get a pattern that you like. Now I'm going to set it to some patterns that I think look quite nice. Actually, I haven't got it as that. I need to set that as 100, I think, to get the one that I want. Yeah, there we are. Okay, so notice that changing the bevel resolution has changed the appearance of my curve as well. So if I take this back up to 180, I'm not quite getting the shape that I wanted, yeah? So taking that bevel resolution down does affect the finished shape of my object, as does changing the height here. So you can you do need to play around here until you find something that suits your needs. Once you're actually happy with a finished pattern, what you do need to do is view it from the top, and I'm going to stick with that pattern at the moment. And you do need to size it. So I'm just going to scale this down now. That will bring in the internal diameter until it's approximately 65 millimeters. Note this value over here is actually the external diameter, so don't look at this value as being 65. Look at the inner circle that we originally created. If you want to make that deeper, you can change the height here. And you just have to play around with these P and Q values until you get the finished shape that you actually want. And do zoom in on it and make sure that it does look quite smooth as the finished object. Okay, so that's information about all of these different values over here in the Torus Knot Plus panel. And you do need to set certain values like the bevel resolution and the 30 resolution here and this one as well to appropriate values before you can 3D print anything. So I wouldn't go below 100 really here, but as you can see, if we set it back to the 180 that I started with, we get a different kind of effect for our bracelet than if we set it to be 100. Okay, so that's it. That's the Torus Knot Plus bracelet created there in Fluid Designer. Thank you.